So what I'm going to do with this problem is combine a couple of different kinds of things. 7 and 8 are similar. So to answer 7 here, first off they're asking us what's the population proportion. Well, we know out of the 12,000 people that live in this suburb, that number just moved here. So that's the population proportion. So I'm just going to take the 6414 and divide it by the 328, and that'll be my population proportion, which, as they're saying here, is 0.52. I use P to denote the population proportion. I can also use these. Different books use different values. Some books use the Greek letter theta. I guess that's about it that I've ever come across. We know that mu is the population mean. Okay, so that's one way to know there's a difference between talking about proportions and means, is they'll be using these symbols. Another reason I know this is about proportions, besides them telling me this, I don't see anything about a standard deviation. But when they don't tell me anything about a standard deviation or give me some data, it's usually about proportions. Okay. So let's answer B. I get the sample proportion. Well, the sample proportion denoted with p hat, and we had a sample of 600. And out of those 600, 290 just moved here. Let me make that look like 600. And you divide those, and that's where they got the 0.483. It is less than the population proportion. Is it enough less to say something's going on here? Is where I mean, the third part of this question is the sample representative of the population? Right now we're just going with a guess, kind of a gut feeling. Well, yeah, this is only 4% less, not even 4% less, so that's probably true. Let's do this a little more mathematically, a little more using statistics. So, and then we are getting into inferential statistics here, because now we're starting to make judgments about a population based on a sample. A lot of times, one difference is we know the population at numbers, so it isn't so much trying to draw inferences. But what happens is, if it's a large enough sample, I mean, it's a large enough population, and you don't know the population numbers, you can use your sample results to make a guess. So that's what we're going to kind of go there next, not quite yet. So how likely is it? I guess in question 8 it asks, what's the probability of getting a sample this far away from the middle? Well, we know the middle of this distribution is the 0.52. And the sample result was 0.483. And we want to know what's the probability of that happening if this is really true. So we're going to do a z-score, but before we do the z-score, we need to get the standard deviation for this distribution. Now, if you watch that Mr. Nystrom's video about sampling distributions and the central limit theorem, you saw him write something like P times Q over N, and we take the square root of that mess. So what we'll do is we're going to use, there's our P. To get the Q, that's just 1 minus P. So what we're going to do to get the standard deviation is we're going to take 0.52 times 1 minus 0.52, which is 0.48, and we're going to divide that by the sample size of 600, and we'll take the square root of that mess. So my calculator tells me that this standard deviation is 0.0204. We're going out 4 decimal places. So now to get the probability of this, we got to do a z-score. So the sample result was 0.483. We're going to subtract 0.52 because that's the mean of the center, divided by the standard deviation, and we're going to get that z-score. Find the difference, then get that answer, divide it by that standard deviation. I got a z-score of negative 1.81. So now we're going to go look at that up in a normal curve table. So let's see, negative 1.8. I draw that line across so I can keep my eyeballs don't jump. Let's see, so negative 1.81. Then I'm going to come down this column and look for the intersection, and I'm seeing 0.0351. So that tells me that that area right there, or that associated probability, is 0.0351. Well, if we use that rule of thumb that if something's a rare event, if it's smaller than 5%, and that would be 3.5%, we might have a case to say that the chance, see, this says the chance of getting a sample that far away from 52% is only at 3.5%. That's questionably, there might be something happening here that maybe our sample wasn't representative of our population. But that's kind of the process, and next week, when we start looking at significance tests, that's where we start using these probabilities.